Ladies and gentlemen, will you please welcome AWE co-producer and your host for today, Tom Emmerich.
Aw, thanks, guys. I'm back on stage. How was your coffee? Did you tweet? Delicious. I love it. For 50 years, we've been trapped in two dimensions with flat input devices like the mouse, trackpad, and touchscreen as our only windows into the digital world. But as augmented reality brings both work and play into the 3D space, a serious challenge is emerging. How will we interact with such immersive technology? Meta CEO Meron Gribetz will take the stage today to explain how neuroscience is helping us build a truly natural operating environment for navigating the future of computing. Please join me in welcoming Meron Gribetz, CEO of Meta, to the stage.
Cheers. Hey everybody, how's it going? Having fun so far? Cool demos? All right, very, very good. So hopefully we'll add to that list of cool demos today on stage. I'd like to talk today about input devices, the history of input devices, and where I think we're going from here. I'll wait for some people to come in the back. Input devices, like the mouse, are like cigarettes. They were cool in the 60s. They created habits that lasted decades, and we're all kind of scratching our heads wondering what they're still doing around. And thanks to our friends at Redmond, they're inching their way into the next generation of computers as well. So what's the problem with the mouse? Well, the primary issue with the mouse is that it abstracts all of our thoughts and imaginations, which are infinite, into an unnatural series of steps, like left-clicking, right-clicking, dragging, and dropping, all of the things that are limiting our imaginations. And even our shiny new touchscreens are not immune to this. So we all know the mouse is fairly old, but how old really is it? Of course, the Mac popularized it in 1984, but it goes back. Bill English and Doug Engelbart and SRI in the 60s created the first mechanical mouse. But I'm here to pose that, in fact, the mouse draws its roots way earlier. The mouse, in my opinion, started 2.5 million years ago in the savannah with our ancestors, the Homo habilis, and their first tool, the tool that came to define us as a species of tool makers, the Mode 1 rock. This rock came from the riverbed. It was polished across its surface, so it was wonderful to grasp in one's hand. And our ancestors picked it up, and they smashed it against another rock, and they created a jagged chip, a chipped edge, which they then smashed into animal gain. And this tool we have a lot to owe to. It took us out of vegetarianism, and that extra protein we were able to consume actually increased our cranium threefold. So besides defining us as a species, this tool actually gave us our persona. And that kind of a symbiotic relationship between man and tool is what I hope we can strive for in the future. Now, the mouse did get one thing right from the Mode 1 rock, of course. It tells you exactly how to grab it. It tells you exactly how to put it in the palm of your hand. But the other half of it, which is how to create a tool that has no learning curve, which our ancestors could just pick up from the riverbed and they know exactly what to do. Well, the mouse doesn't do that. If you take a mouse-based interface and you apply it 2.5 million years ago at Homo habilis, I doubt they're going to get it. And so I hope as we build the next generation of computers in augmented reality, we will in fact learn the other half of the secrets of the Mode 1 rock. A couple months ago at TED, I introduced our second product, the Meta 2. But I wasn't really there to introduce any kind of hardware. I was there to unveil a brand new paradigm of interface design that is anchored on the science of our senses, on neuroscience. And why neuroscience, you might ask? It's because, oops, my phone is ringing. Not cool. Why neuroscience? Because we evolved into this 3D world with our vision, our cognition, our perception. And now that our interfaces are catching up around us in this 3D world, we have to go back to the map of our senses and our perception, which is, of course, neuroscience. So when you take this kind of an interface that has zero learning curve, like the Mode 1 rock, and you apply it on a pair of AR glasses, you get what I call the natural machine. And when you replace the mouse, the input inside of this natural machine, what are you left with? Here's the best part. Here's my favorite part. We're replacing the mouse with absolutely nothing. Because we don't need anything, because we can touch our world. We evolved to touch our world in an unmediated fashion, not by controllers like we're seeing in the virtual reality world, not by abstract gestures which have to tax our cognitions directly. And when we can actually put our hands into the world and start interacting with our interfaces, we're going to create a feedback loop which is going to change the relationship between man and machine. When I stick my hand inside of an interface, I can be shaping that interface dynamically. And that interface's affordance, the way it positions itself and tells me to grab it, is going to then change the angle of my body. So that forward feedback loop is really beautiful, and I want to show you a little demonstration of it. Let's try it out. So this is the Meta 2 device, and hopefully behind me you can see the cubes that I'm looking at. For the purpose of this demonstration, we actually blocked out the background so that you can see exactly into the interface. I'd like to tell you a little bit about this device because I am a CEO of an AR company, so here's my little plug, and then we're going to forget about it. It's a 90-degree diagonal field of view. It's got 2.5K resolution and 1 millimeter accuracy in our hand tracking. So what can we do with this? Of course, that's all hardware specs. That doesn't really matter because what matters is the interface. And here's the interface that we can build with this kind of a system. So where you see black in the background, I'm seeing you guys. And as I'm swiping my hand through this interface, it looks like I'm sticking my hand through a field of wheat or maybe a dust field. And this kind of an interface, this one would be perfect for something like a 3D instrument. You can imagine a 3D harp. But it would be so much more powerful than a 3D harp because with the flick of a wrist, a conductor of an orchestra can make an entire section of the orchestra move in syncopation. And that is an amazingly more powerful proposition than a 3D harp. So that's what this is going to open up in this first kind of interface. In the second kind of interface, I could splash my hand through it. And this would be perfect for something like a fluid dynamics class where I could change the viscosity in real time and explore new material sciences. And this next interface would be perfect for exploring what gravity might look like on Mars. And look at the dexterity here. I could isolate a single cube here and control that. And this next interface, which is very beautiful, at AWA a couple of years ago on a panel, I said the killer app is a sculpting tool. So let's look at what that might look like. This could be a beautiful interface for a sculptor or maybe a bagel maker. And my interest here, in tying back to AWE of a couple of years ago where I said it was the killer app, is can we imagine in 10 years from now what disjoint, non-art industry professional will say sculpting was the killer app for my industry, for industry X? And I think that now that we're getting our hands dirty for the first time and we could build these kinds of interfaces, That's what we're going to be exploring together. So thank you very much. Cool. Thank you. So what does this have to do with an inanimate old rock from the riverbed in the savannah 2.5 million years ago? This is what it has to do. The common denominator between the three interfaces, which we just looked at, is that they anticipate the user's instincts so precisely that they're as natural and easy to use as that Mode 1 rock was for our ancestors 2.5 million years ago. And I think that when we begin to build interfaces like this, the sky's the limit in what we can achieve and which industries we can touch. So the question is, how do we pick between those three interfaces and the plethora of interfaces around them? Here's another plug. We at Meta have a team of neuroscientists that is working full time on isolating what are the easiest tasks, the no learning curve user interfaces, and matching them to particular tasks. And then we're publishing them in an open source design guidelines we call neuro interfaces, which we then publish back to all of us in an open source fashion, because we hypothesize that by putting all of this science in front of the whole community, we're going to create experiences that are so much better than what AR can offer today, and that will ultimately shift the paradigm faster for and with all of us. So I'd like to talk about the first such interface principle, which we call affordances, or minimize abstraction. A user comes into a new interface with a world of experiences and knowledge about their surroundings. Rather than ignore that and replace it with a series of abstract gestures or metaphoric icons as we have on touchscreens today, rather than having to learn this whole new taxonomy, I believe it's our job to build tools and content that invite the user's actions, which they're already familiar with. Just think about that Mode 1 rock in the riverbed for a moment. The way it was positioned there, it told us what to do with it. The best possible tool we can build for augmented reality or any virtual reality or any other medium is a tool which tells you what to do with it without explanation. And that is our first principle, affordances. Our second principle is touch to see. So what do babies do when they see something that grabs their interest, right? They reach out and try and touch it, and that's exactly how our device should work. Turns out that the visual system gets a fundamental boost from the sense we call proprioception. That's the sense of our body parts in space. So by touching our interfaces directly, not only are we going to be able to control them better, but we'll actually be able to understand them a lot more deeply. And here's a new piece of neuroscience. We actually have depth maps that are specific for the hand region, what we call the peripersonal space, that allow us to understand the things that we touch in much higher precision, because you're constructing a depth map dynamically around the object which you're touching. So we can start understanding why touching objects is so much more than controlling it with fine precision. It's understanding it in much deeper and more profound ways. By the way, here in this video, you can see it was shot with the GoPro behind the lens. And this is the real field of view. You could see kind of the nose area over there. And this shows you how my demo felt when I had it on my head. I invite each and every one of us to try a demo in our suite later on and really experience this firsthand. So, does this make our hands the ultimate input device, as someone much smarter than me once said? No, I think it's much more nuanced and powerful than that. Because when we use our hands, specifically when we use them naturally, with affordances and with direct touch to see style, we won't need to use input devices anymore. We're transcending them. And I think that's a very profound point. So devices like the mouse had a great run, but we evolved to reach out and be intimate with our world, to play with it, to shape it, and to be shaped by it. Rather than sending it commands at a distance or abstract gestures or icons or metaphors, we evolved to touch it directly. So I hope that as us, the community, the designers of this next generation of interfaces, build our interfaces, we go back to the very tool that defined us as a species, the Mode 1 rock, and continue to unlock its secrets. Now, the Mode 1 rock lasted 1,000,000 years. It was our best friend for 1,000,000 years, until the Mode 2 rock came along, which was a brilliant invention. It was actually a wearable device. Unlike the Mode 1 rock, which we discarded after every use, the Mode 2 rock, which we chipped on the other side and became a hand axe, stayed on our person all the time. Just a fun side anecdote. But it lasted 1,000,000 years, and that is the hallmark of a very natural tool. So I hope we can continue to learn from it. But we let it go 2,000,000 years ago, and I think it's time to let go of the mouse. So I'm announcing here at AWE that by AWE 2017, all couple hundred of us at Meta, the designers at that time, the designers, the engineers, the executives, the staff, will all be throwing away our mouse and replacing them with absolutely nothing. Thank you very much.